An equation in quadratic form is one that can be turned into a quadratic equation even if the original one was not quadratic itself. We can do that by making a substitution, letting u be equal to a variable expression whose square is also present in the equation. In this first example, we see that we have the variable expression x to the negative 1 power. And x to the negative 1 squared is x to the negative 2. So if we let u be equal to the variable expression whose square is also in the problem, then we can substitute u in for that variable expression and then u squared in for this x to the negative 2 power. When we do that, we end up with an equation 2u squared minus 7u minus 4 that actually is a true quadratic. And that's what makes this equation one that's in quadratic form. So now that we've made this substitution and turned it into a true quadratic, we can now solve this equation for u. And this quadratic actually factors, so we're going to use the AC method to factor this trinomial, which means that we take the a coefficient, the c coefficient, we multiply these two terms together. To get 8, we're going to look at two factors of 8, and since this is a negative sign here, we're going to look for two factors of 8 that subtract to the center term, which is negative 7. So 8 and 1 are the factors of 8 that subtract to 7. And actually we want to get a negative 7 out of that combination, so we're going to let the 8 be negative and the 1 be positive. So in this AC method, what we do is we take the negative 7u that's in the center of the equation, and we're going to split that up into negative 8u plus 1u. So we replace negative 7 with negative 8u plus 1u, which is still negative 7u. And I'm just going to call that u here. And then we bring down the 2u squared and the minus 4 equals 0 so that we have our complete equation. Now we factor by grouping, so we're going to group the first two terms together and say that 2u is the common factor that comes out. When we factor out a 2u, we're left with u minus 4 out of that first group. Grouping the second two terms together, they don't have a common factor, so what we'll do is put a plus 1 placeholder right here. It makes the next step of factorization a little bit easier to see when I have a plus 1 in that position. Now we're going to notice that we have a u minus 4 that's common to each of these terms, so we'll factor out u minus 4, and what remains out of this first term when we factor out the u minus 4 is just the 2u, and what remains out of this second term after we factor out the u minus 4 is that plus 1. We're still equal to 0, and now we have this that is factored into the product of two things. Once our quadratic is factored into that product, we can set each factor equal to 0 and solve them individually for u. So finishing up this second equation, we're going to divide both sides by 2 here, and we end up with u is equal to negative 1/2. U is also equal to 4. Let's go back up to our steps and identify where we are in our process. We've already made the substitution and solved the resulting equation. We just solved it for u. Now we actually have to go back to the original variable x, and we use that same original substitution in order to do that. We use this substitution here. So I just brought our substitution down as well as our solutions for u, and just to make it a little bit easier and more clean to see that when we back substitute to get back to x, which is the variable that we were initially trying to solve for, we'll say that since u and x to the negative 1 are equal to each other, they're actually interchangeable. So instead of saying u is equal to 4, I can replace that u with x to the negative 1 and set that equal to 4. Instead of saying u is equal to negative 1/2, I can replace the u with x to the negative 1 and set that equal to negative 1/2. So we just back substituted, and now what we're going to do is solve these resulting equations for x, the original variable. To get our x to the positive 1 power, one thing that I can do is raise both sides to the negative 1, because when I raise a power to a power, I'm going to multiply the exponents on the left-hand side, so that is going to yield x to the positive 1 on the left, and 4 to the negative 1 on the right, which is the same thing as 1/4. Let's solve this second equation for x by doing the same thing, raising both sides to the negative 1 power, which is going to yield again x by itself on the left, and negative 1/2 to the negative 1 power, which is the reciprocal of negative 1/2, or negative 2. So these are the two solutions to that original equation that was quadratic in form.